So, here's my problem. So, first question. How many answers should I end up with on 22? 4. Because it just goes with my largest degree. So I should get 4 answers. So I'm like, okay, well, I always want to check and see if the calculator can help me first. So I'll bring the calculator over. If I type it in, I'm going to hoping that it's going to show me 4 intercepts, because then I'm just done and life is easy. So I type this in. Oops. Make sure I do it right. Double check, make sure my exponents are good. Yes, yes, yes. And let's graph this and hope for lots of zeros. There's 1, there's 2, there's 3. Uh-oh. I only have 3. Okay, let's make sure which ones they are. Let's bring up the table. Let's see what we have so far. I have one at -1. Whoops, -1, Hardy. I have one at 3. And I have one at -3. When we were doing these before, we were like, when I don't see one of the answers, maybe there's an imaginary one. Okay? But then I start to think about it. But if there's an imaginary one, they come in pairs. That gives me 5 answers. What the heck? So I come back to the graph for a minute. And here's the tricky part, because I'm not going to find it. If I went through and did all the dividing out with synthetic division, I could find it possibly. But here's the trick with this. There's this little thing in math called multiplicity. Okay? Also might be called a double root. And it occurs when you have part of your graph come down, and it looks like it barely touches the axis and then goes back up. So it's like, I'll just touch you and go back up. What happens with that is it ends up causing a double root. It kind of nicks the x-axis twice, but it's so close you can't really see it. So if you ever put a graph up on one of these and you're short an answer, if you look again and you say, ooh, that's barely touching the axis and going back up, that answer will actually get used twice. If I were to go through this, and I'm going to show it to you so you can mathematically see how it works too, but I want you to see the shortcut so you don't have to go through all this. If I didn't notice this one at first, here's what I'd have to do instead. I'd go through and I'd say, okay, I'm short an answer. I got to use the synthetic division. So I'm going to use this -1. Now I'm going to do a thing here. 1, 4, -6. At least there's no gaps that I have to worry about. And I'd start working this out. And you're just going to kind of see how, in the end, I would find out how this works. Oops. That hurt. And again, if I'm doing this correctly, I shouldn't get a remainder at the end. And I don't. I get a 0. So you're like, okay. Started with x to the 4th. Now I'm down to x to the 3rd. Where's x? There's my constant. But unfortunately, as we talked about before, until this is a quadratic, until this is x squared, I have to keep going. So I'm like, oh, bummer. So I move up a little bit, and I say, okay, I got to do this again. I know one of my roots is at 3. Okay, so let's try that. I could have used the -3 as well, but now this is the one I'm working with. So 1, 3, -9, -27. That's 0. I don't need to use it. This is going to be the last time I'm going to have to do this, and I will have proven my point. Multiply, and add, multiply, and add, multiply, and add. Now again, I'm going down again. So I started with x to the 4th. My first time I did my division, it's x to the 3rd. Now it's x squared. Okay, this is the part where we kind of just keep plodding away at this. Now it's a quadratic. Now I should be able to factor this and get my last 2 answers, because I already know -1 and 3 are answers. If I factor this, What multiplies to positive 9 but adds to positive 6? 3 and 3. So if I were to set each of those equal to 0, I'd get x equals negative 3 and x equals negative 3. I get it twice. There's my other two answers. There's why I get two negative 3's. The graph shows me that's the case, but if I forget, this is always an option that's sitting there for me if I need it. Okay, so if you ever look and you're like, crap, I'm only getting 3 answers, it should be 4. Or crap, I'm supposed to get 3 answers, but I'm only getting 2. Look for that in the graph, but you always can do it mathematically too at the end. If you're looking in the graph, you're looking for a place where, and it might be from down below or it might be from the top, but it looks like it barely touches the x-axis and then changes direction again. So like over here at negative 3, it comes down, touches it a little, and goes right back up. If you see one of those, that's where you, well, there it went. That's where your double roots typically are going to come from, or your rule of multiplicity. Nope, if one of those shows up, you can just look at it and say, ooh, that's where a double root is, write them both down, that's fine. I want you to keep this the simplest way possible. I don't want you to have to do a ton of work on these. But I just like giving you the algebra option in case you forget about something, or you don't have a calculator readily available for part, or something like that. Okay? You have to write it twice. It's a double root. Yeah, I have to put it twice. If I don't write it twice, I don't have the answer quite